Sometimes when we're shopping, we can have two different ways to save money. We can have a set dollar amount off, in this case $10 off, or we could also have a percentage off. And so this example is going to take a look at how we can use function composition to figure out if it matters whether we used the straight up dollar amount off first or if we use the percentage off first. As we did in our last video, at the end we talked about how it's not, function composition is not the only way to do this, and in fact there may be easier, quicker ways to do it, but let's take a look and see how function composition could be used to answer this question. So for starters, let's go ahead and write an equation for each of the two methods we could use. So the first method, or the first discount I suppose we could use, is this straight up dollar amount off. So I'm going to call that, let's go ahead and label this. This is the $10 off coupon. And what I'm going to do is I'm just going to use f of x to represent this. So if I spend x dollars, or if the item I want is x dollars, obviously if I have a $10 off coupon, I'm going to represent that as x minus 10 would be my final amount. The second one, we're going to use a little bit of a trick to figure out. This time I'm going to use the 15% off coupon and then write a function to represent that. So again, let me label this. So this is the 15% off. And I'll call this one the g of x function. Now, the trick that I like to use when I'm working with percentages is I think of it like this. If I'm saving 15%, in other words, I'm not paying for 15% of it. So what I want to figure out then is what percent of it am I paying for? Well, if I'm not paying for 15%, then I am paying for 85% of this. And so what I'll do is if it's a total cost of x dollars, I'm going to represent this as 0.85 times x. Once again, that's the trick that I use to represent the percentage off. If I'm not paying 15%, then I am paying 85%. So there's the two functions that represent the two different situations. Let's go ahead and take a look now at composition and how that can be used to represent or to show which would be the better deal. Do the $10 first or do the 15% first? All right, so here are the two questions. Should I use the 15% off before or after I use the $10 off? So here's, again, how composition can be used to answer that question. First up is, let's suppose I use the gift certificate, the $10 off, first. So what that's going to mean is in function composition, I would want that to be on the inside because I want that part to happen first. And so the composition this first one is asking is basically this, g of f of x. So as we've done in the past, let's go ahead and write, what's on the outside. So 0.85, that's the g function. And then a big old blank space where that x is, where I'll write the other one, the $10 off. So here's the function that would represent taking the $10 off first. If I simplify that by distributing, I have an expression or an equation that's 0.85 times x, the amount of money I'm spending, and then minus 8.5 once I distribute. So there's one option. Okay. Let's go ahead and see what happens if I switch the order and do the 15% off after, or use the gift card after. In other words, I'm going to switch the composition, which, as we've discussed in other videos, should make a difference. I'm not going to end up with the same thing. So let's try doing the 15% off first. So I'm going to write down the f function with a big old blank space where the x is. So I get blank minus 10. And then within that blank space, I'll write the other function, in this case the 85%. Or 0.85 times x. Now in this case there's nothing to simplify, so I'll just drop the parentheses and get 0.85 times x and then minus 10. Well, even just looking at those two equations, we can probably figure out what's going to be the better bet, which one should save us the most money. That second equation, I'm subtracting 10, so I should be saving more money by doing that, but let's see if it actually works out. So as our final one, just to actually plug a number in and see, they asked me to buy a $55 video game, so that's the x value. So plugging that into both functions, and I can use the simplified equations we already came up with, using method 1, where I do the 15% off at the end, I end up with a total cost, and you can check my work on this if you want to, if you don't trust me. I end up with $38.25. However, if I plug 55 into the second method, the one that we predicted should save us more money, that's if we do the 15% first in this case, and then take the $10 off, I see that that gets me a total of, or that costs me then a total of $36.75. So as predicted, yeah, that's going to be cheaper. So yes, it definitely does matter. Some of you knew that a way long time ago without having to do function composition. But there's, I guess, our proof that, yeah, you should probably take your percentage off first before you take your straight up dollar amount off. Most stores know that that loses them more money, so they won't let you do that. But hey, as far as math goes, we have the math to back it up, and if only we could beat those store policies.